and we're back online with the second panel of the day. Today has been focused on healthcare and pharmaceuticals and life science, all things to do with the human body and healing ourselves. So, right now, we're going to be discussing explainable AI in healthcare, and we're going to be having a great panel of industry experts that have been delivering solutions at the bleeding edge of technology. So now I'd like to invite the panelists to do a brief introduction into who they are and some of the things that they've worked on, and then we can dive into the discussion. Starting us off is going to be Manas Gaur.
Hi, thank you, Joaquin. So, hi everyone. My name is Manas. I'm an assistant professor in the Department of Computer Science and Electrical Engineering at University of Maryland, Baltimore County. Before I joined the university, I had a few months and a year and a half experience in Samsung Research America. I was working with the AI Center in the Mountain View, working mostly on the RAG, the Retrieval Augmented Generation, back in the time of 2020s and 2021. So after that, I joined UMBC, and briefly before I was a visiting researcher at the Alan Turing Institute in UK. My core area of research has been in the intersection of knowledge graphs and artificial intelligence, where we look at various properties of consistency, reliability, explainability, and interpretability in AI. We have created a lot of benchmarks that have been used across the board by various organizations, including Data where I was working on the sub-event detections or event detection work in the crisis management. So and I am also directing a lab at UMBC, which is a knowledge-infused AI and inference lab, where students work on research in the intersection of explainability and interpretability, and most involved in knowledge-infused learning.
Thank you, Manas. Manas Talukdar.
Yeah, hi everyone. My name is Manas Talukdar. I'm Director of Engineering at Labelbox, an AI startup based out of San Francisco. So before Labelbox, I worked for an enterprise AI company, C3 AI, where I helped build out the leading enterprise AI platform in the world. Before that, I was at an industrial software company for over a decade, where I worked on things like time series historian, middleware SDKs, IoT platforms, and data platforms, all geared towards industrial AI use cases. Here at Labelbox, I run engineering, and what we do is we basically work on the post-training phase, work with enterprises, helping them develop task-specific custom models. We also work with AI labs, and by AI labs, I mean the large companies building LLMs. We help AI labs develop multimodal LLMs as well by providing them high-quality ground truth label data.
Thank you. Roberto Shimizu.
Hi, my name is Roberto Shimizu. I'm the CEO, co-founder, and chief AI officer of IntelliDoctor.ai. IntelliDoctor is a clinical decision support system based out of São Paulo, Brazil. Before I founded IntelliDoctor. I had a more than 20 years career as a business executive in multinationals, especially in the finance and insurance sector, and also I'm a engineering by training with an MBA and most recently a master degree in computer science with emphasis in AI. At IntelliDoctor, my job is to deploy a tool that is useful for physicians in their daily-to-day work, providing them the right information at the point of care. And our customers are hospitals and clinics, most likely, because they really want to that their workforce, which are physicians, are providing the best support for patients in a most productive time and in the most reliable way. And of course, there's a lot of variation in terms of competencies and capabilities of the medical force. So a tool like that is really, really important. I'm happy to be here exchanging ideas with all of you.
Well, thank you very much. I think just by understanding everybody's background, we have a bit more context into the depth of subject matter expertise we can dive into. I would like to start by saying healthcare is a vital aspect of our society. We can't have a productive society if people are sick or dying. So, it's important for us to have a robust infrastructure for remedying people that are ill. But to do that, there's extensive training, there's highly regulated environments. You may or may not be aware of the fragility and the antiquity of some of the existing IT systems in healthcare. And now we're looking at the latest wave of AI adoption, which is generative AI and large language models. We're really trying to make sense of this tidal wave of innovation. So I'd like to ask the panelists, what are your observations in the shifting trends from traditional IT healthcare systems and how people are looking to adopt these technologies? Anybody can jump right in.
Okay, so maybe I can kick things off. So what we are seeing right now, specific to the medical domain, there are certain use cases, for example, where uh, there is a need to develop, there is a drive to develop LLMs, which can specifically cater to the medical industry. I can give you a very specific use case, and I mentioned this in in a talk earlier, that the need to, for example, infer off of X-rays and detect whether a patient has actually some problem on the lungs or not, and so forth. So obviously, this is a highly specialized domain, and the margin of error in this domain is very low. So what's really important is that the LLMs need to be post-trained and fine-tuned on very high quality ground truth label data. So, and for providing this ground truth label data, we cannot simply have just some Joe Blow from some corner of the world going into some image and then doing some annotation. We need people who are actually understanding what that X-ray even means and able to read and interpret that. So there is a dire need in the industry right now for people with these specialized skill sets. And we're seeing this across different industries, not just in the medical industry, but specific to the medical industry, whether it's X-rays, whether it's for cancer detection and so forth. There is a drive definitely to create LLMs specialized and able to infer on these specific use cases.
Yeah, maybe I can add with my experience of watching doctors using the platform in their workplace. And one thing that when you contrast in the traditional way versus this new way of using AI, it's been very interesting because at the one time they some of them see the technology with skepticism, and it depends on perhaps the generation of the doctors.
Mhm.
Doctors like middle age, more gray hair like me, and extremely specialized, they tend to not need so much because they have a lot of flying hours. They have a very deep expertise in the domain they use. And when they face an application like that, the first instinct is to test the application, test in a way that they ask questions that they already know the answer, just to know if the AI matches their skill level. And after that, after they feel comfortable, then they go to the second steps that they try to use the AI in a more productive way. While the younger generations, the generation that they are more digital native, they are more familiar by using applications. They tend to use a lot in a way that we are also seeing that almost create a kind of dependency. And also because they don't have much flying hours. They are inexperienced. They don't have much repertoire. And having a tool like that who can, bring to them information based on evidence, it has been very, very helpful. And lastly is that, although we work very hard in providing a reliable and trustworthy AI, there's a lot of noise in the market that the final customer cannot differentiate the good AI from the bad AI. And this is something that it's being challenging for whom is trying to market, a cutting edge solution to the mass market.
Yeah, I think I would talk about in the context of when I'm looking at adoption of AI systems in the healthcare setting. My close observations has been in the context of mental health, where when I was working with Weill Cornell Medicine and I was working with the Maryland Psychiatric Research Center now. The challenge over there is a lot of the information communicated in mental health is in common language, right? And some of the triggers, some of the causes, symptoms that people talk about are not so explicit as in the clinical records. So that poses a significant challenge as to which part of the sentence is actually important for making the decision. So we found that various transformer models that have been developed, they actually highlight every single word equally likely to make that decision, and they say that this entire sentence is to be turned red for us to find the right answer. So we kind of looked at this design that if someone would like to answer a particular questionnaire in mental health, which is the, let's say I talk about patient health questionnaire, which is about patient's own health, and they fill them themselves, can an AI through conversations populate that questionnaire, right? So that's a simple way to figure out whether AI is capable of understanding the different questions that are there in the questionnaire and match it to the and use a user input to figure out filling up. So with this simple example, we found a significant drawback that forget about prediction first. The penultimate stage of questionnaire, it was simply left out. So that was one aspect, and the second thing that we looked at was that, okay, now for every question there are some entities that they are really interested in, so we try to provide the definitions to those entities. Now when we looked at those entities definitions, we saw that the model is good with the right definitions, but it is even better with the wrong definitions, right? So that means that the wrong definitions were also doing the charm of giving up the right answer when even the right definition having the lower bar. So we were not really sure that what type of information is actually the model digesting to give you the outcome, right? So we kind of made this kind of a permutation exercise with a correct definition, slightly wrong definition, and the wrong definition completely, right? So in some of the cases, let's say Llama 3 seems to be a better stable model to me in this case, where it went through to the right definition all the time. But Mistral, Mixtral, or Phi, or the other models, they tend to be following the slightly wrong and the wrong definition more than the right definitions, right? So there is some sort of a misalignment that I think that is there between the models, the misalignment between the families of the models, and also misalignment across the model. So let's say if someone chooses one model over the other, the entirely different outcome is what you are seeing. So there is this sort of an issue on robustness in the model that I would like to highlight. And second thing that I want to say, that this coming up from the Roberto's presentation earlier today on attribution, right? And there are cases where you can ask, and attribution is really challenging and is an important piece of task in the healthcare. You can't deliver an outcome without attributing something that is from where the outcome is coming from, and that's where a lot of hallucinations are showed up. A lot of answers are a lot of citations are cooked up which do not exist in the real world, right? So those things, in my opinion, and these things which we consider as a limitations in AI turns into be a safety related issues in the context of healthcare, right? So that is something that I will sum up this thing into robustness issues. Attribution is really a key, and the third one is the safety if the above two are not met.
It's no wonder that we have fear and skepticism of AI with the latest accessibility that anybody can claim expertise and deploy some sort of toy model and say, this is AI and this is what it represents. As Roberto said, it's hard to differentiate true subject matter expertise and people that are building guardrails and training it and fine tuning it and coming up with all these rule based guides to prevent it from going down the path of hallucination, not showing a provenance of where these answers are coming from. But at the end of the day, it's no different from if we were to look to an individual for an answer or expertise or guidance. If somebody has expertise in a particular area or deep knowledge, they are able to tell you what's going on, why it's going on, where they retrieve their information from, and that sort of breeds the trust, right? Being able to explain the means of deriving that answer. So, in terms of explainability, are there any particular insights that you've derived from implementing both statistical artificial intelligence applications as well as symbolic artificial applications?
So I can go over here first. So so I think that's a very good point, Hoken, that you actually talked about on statistical explainability and symbolic explainability. So in my close interaction was a recent work that I we just got published in the IEEE Journal of Biomedical and Health Informatics, where we looked at that. We can plausibly introduce very careful questionnaire modules within the transformer model. So we saw that. So if you look at, let me give you an example of Lime and SHAP, right? I consider them to be a statistical explainability models. The reason is because you are talking about, you're giving an input, you're looking at the feature importances of the text, and then you're saying that these features are really important for making my decisions. But when you talk about healthcare, where if you ask a person to express, if I'm sitting and if you're asking a person to express his conditions, he can express his condition in various implicit ways, right? In that scenario, you get all red in terms of the Lime and SHAP, because every single word that you say is important, right? But now, if I turn this information into an architecture where I'm looking at each and every questions that I'm really concerned about, right? It's just like a human interaction thing, right? Where a person already has a premeditated questions, and he's seeking answers from you, and he's just filtering those answers based on these questions. Now I want the AI to do the same thing. Yeah, so what we did was we introduced between the two layers, we introduced this cross attention modules, where we looked at these small questions, where we saw that if these questions are being answered, then only we are propagating to the next layers. So that way we were able to figure out that by every question, I can look at the attention of these models, right? So that seems to be a symbolic design to me, because now you have a question, that's a symbolic knowledge that you are really concerned about, and you have an answer from your input, which is being highlighted based on this question, and then you say that whether these words do really make sense to the question that you're really concerned about. So that's our close work that we did on symbolic explainability over statistical explainability.
So, from the industry perspective, I would say some of the techniques that's being incorporated for helping explainability in healthcare context, which I touched upon one, but the technical term I think is called gradient-based saliency and heat maps, where it's visual techniques basically, where you highlight, say for in the example I gave in an X-ray, you highlight what was the most influential for the AI's decision making. So if it's a chest X-ray, then the heat map might highlight, say, where was the pneumonia detected, for example. So that's one way you keep track for explainability. And then I think Manos also talked about line,
Yeah.
which is like you change the input and then you figure out how the prediction changes, and then you create sort of an interpretability model around it. And then there's one more technique which is also adopted in the industry. It's called counterfactual explanations, where
Yes.
or more like what if scenarios, right? So you might show a patient's risk score, and then that might change if certain factors are different, providing actionable insights for both clinicians and patients. So these are some of the techniques that's actually being implemented and being looked into in the industry for more explainable AI, particularly in the healthcare context. So one, and going back to one point Manas mentioned, I think I can provide some insight here. So one of the reasons, and this aligns really well with what I was talking about in my talk earlier, that one of the reasons we see such vast divergence among the different model outputs, even models of similar size parameters, uh, you know, when we ask a question for a specialized domain, is because these models have not been, their baseline training has not happened on any specialized data. Their baseline training has happened on whatever free data is available on the internet. And so if you ask a very generic question like who is Bill Gates, then the answer will be similar. But if you ask a specialized question on a particular domain, then the variance will be very high.
Yeah.
And that's the gap which the industry is trying to close right now with specialized training data.
Yeah, this is very important. I mean, for the business perspective, although maybe the user doesn't feel that much, especially, I mean, the younger ones, but in order you to commercialize in a B2B environment, the decision maker of a clinic or a hospital, the clinical director, for him is very important to know what are the, let's say, the foundations, the justification. So we need to be able to backtrack what our application provides back to the original questions, and the only way we can, I mean, the only way that I know is through the symbolic one, because then you can traverse a knowledge graph, and you have clearly the connections between the disorder and the symptoms. So this is one point. Yeah, I mean, that's what I think it's important.
So I was just jotting down some notes as you guys were talking. Healthcare is an exercise that doesn't exist in a vacuum. There are legal, financial, emotional implications to any kind of decision that is made at any level. We need to be sure what is an accurate diagnosis to start, and then a subsequent treatment plan for whatever the diagnosis is. So, you know, whether it's stemming from diet or environmental or psychological. It as Manas Talukdar was saying in his presentation, it requires a deep, nuanced knowledge on a specific domain that doesn't have existing specialized data sets for. All we have may be unstructured data, academic text, maybe on-ground field notes from the practitioners that are developing and driving these new or pioneering these hyper specialized fields forward. But how do we turn this inert documents that lie on someone's desk and in someone's library into something that can be explainable and that can augment, not just create a dependency on, but augment the capability of our existing medical staffs, medical practitioners? There's, especially now that we have such a demand for nurses, for doctors. COVID rampaged and ravaged a lot of older healthcare providers. So, what do you guys think?
I mean, this is a
Go ahead.
no, this is a challenge because although not every country, not every business have the resources to fine tune the model. So what we have found is that in some hospitals they have a lot of internal documents, protocols from how they should treat a given patient based on the local conditions, the affordability of the patient, the assortment of medicaments that are at the disposal locally. So it's very important to get this information, which is written in as you said, in somebody else's desk, to bring on the tool. And the way we do it today, I'm not sure is the best way, but it's the way we do. We try to transform that in some sort of a machine readable mechanism, because normally those documents are written PDFs and things like that. So we're trying to transform that in a readable. And the way we architect that could expand from a simple, let's say, vector database, which has some limitations depending on the size of document, the diversity, to a knowledge graph. The knowledge graph, I think it's something that we are trying to evolve, especially because, as you said, the training data that was trained perhaps doesn't have the specificity of the locally, but also in terms of let's say rare diseases. this is something that as more you have, resources that the LLM can rely on, you can, like the likelihood that you have a better outcome is increases. So this is something that we are trying to do.
Yeah, so piggybacking off of what Roberto just said, I mean, one of the issues is, the larger, the more massive a data set gets, vector databases do not necessarily provide the relationships. I mean, vector databases help in clustering. So you can do similarities such as that, and vector databases work really well for that. But if you really want to find the relationships between entities, then there really is no way around using a knowledge graph. It's a very powerful knowledge graph. But perhaps the elegant solution out there is to use a combination of both, because again, knowledge graphs don't necessarily provide the elegant clustering solution that vector databases do. That's one. Secondly, I would say, if going back to your question, Joaquin, if say somebody's handwritten note lying on their desk, obviously that has to be, OCR has to be applied to it, and then once OCR is applied, you ingest it into your pipeline, which goes into training data, or perhaps fine-tuning data for LLM. Now, fine-tuning obviously can be expensive because you're incurring GPU costs. So that's also something to think about. And we can have a whole discussion around a RAG versus fine-tuning, or
Yeah.
RAG and or fine-tuning. But if you want to do fine-tuning, that obviously will lead to intellectual property that somebody can own. So that's an advantage. But these OCR digitized information definitely should be fed into an LLM, can be fed into an LLM as post-training data. Sometimes they may need to be annotated as well.
Yeah.
And then depending on what the use case is, whether clustering needs to be done or whether entity relationships needs to be mapped, depending on that use case, the decision will have to be made whether somebody uses a vector database or somebody wants to use a knowledge graph.
Absolutely, adding to this, in my understanding, I think knowledge graph is the best option to turn information into more meaningful representations. Relationship is certainly definitely what Mana said. Absolutely, does not achievable. It's not achievable through retrieval augmented generation, and I think that's why GraphRag was kind of an exploratory idea that Microsoft released. But also pointing to that, I would say that we are really interested in having graphs that are, or knowledge graphs that are being constructed by experts, as opposed to knowledge graph constructed by generative AI, because a lot of this information that are turned into graphs are not exactly what you call true representations, and there's no way to evaluate that a generated knowledge graph is essentially this exact knowledge graph that would make the decisions. So as a consequence, there's always a trade-off between, let's say, if I have a knowledge graph from Unified Medical Language System, which is the UMLS, that's going to be very small and very targeted information that you will be getting. Whereas if you have a LLM-based knowledge graph, you will have a verbosity in the outcome. With the UMLS, you are able to reason it because you know how to query the knowledge graph. It's just like a databases, right? Whereas if you want to query the LLM, most of the time you won't be able to get the trail that is required to reason over the graph. So I think the knowledge graph is the workaround, and I think knowledge graph embedding can be also be brought into practice for representations, as opposed to simply driving by the OpenAI embedding models.
So we've talked about the adoption efforts and some of the insights that we've seen in observations. We've talked about structuring all this knowledge into a machine and human interchangeable format. We've talked about the ingestion and some of these techniques. Let's talk a little bit about the retrieval aspect, because as Manas was talking about, there is this duality of saying, do we want to go with fine tuning, or do we want to use RAG, or do we want to use graph RAG or knowledge RAG, or whatever other permutation of the hot word has become. So what do you guys believe in that sense? One, the other, both, or neither? What are your thoughts?
Right. So maybe I can go first here. So I think it depends on what problem we're trying to solve, right? So RAG comes into play primarily if we think about it, because LLMs have a upper bound time limit of when the baseline training data has happened. One. Second thing, I would say RAG should be used if there's a very high frequency of new data coming in. Then we cannot fine tune constantly, so it's important to it becomes uh, really unavoidable to use a RAG at that point in time. High frequency of input data, so you establish a RAG pipeline, and that's the way to go. Now, fine tuning, I think, should be used if, say, there's a very specialized domain. For example, if, say, I'm working off of a foundation model, but I want to actually uh, infer off of, say, satellite imagery, the foundation model has not necessarily been trained off of satellite imagery. So then it becomes necessary to fine tune that before even using RAG, if the input volume of data necessitates a RAG. One other advantage of using fine tuning is you can actually, obviously, you create a private instance of your model, and then you own the intellectual property then. So you can monetize it, commercialize it however you want. So it's not necessarily a one versus other in my mind. It depends on the use case. And in fact, in some conversations I've had with certain startups and certain companies, I have actually recommended that you go with establishing a RAG given the volume of your input data, but you also look into fine tuning so that you can own your own intellectual property in the future.
True.
No, I mean, spot on, absolutely. I think when you need information that are related to patterns, a fine tuning is much, much better. While if you really would like to have factual information, like the exactly number of the posology of a given medicament for a given type of patient, then you always will be in doubt if the fine-tuning model, for more robust you have a fine-tuning it, if you're gonna have an error in a in the exactly number. So that is the use case that at least in my conception we rely really on RAG. As regard to patterns, that's one of the things that we didn't talk, but more and more we have LLMs to listen to medical consultations and transcribe that information to text. So that's what I think fine tuning models can really play a role, because you have accents, you have a regional difference, you have the way people describe their diseases is not really technical. Sometimes even the patient cannot really describe with technical words what is it's feeling. So if the LLM is not really trained to get those nuances, it can transcribe wrongly.
So, in addition to that, I want to also talk about that in the context of fine tuning of LLMs, there is a notion of confirmation bias that's comes to limelight. The thing is that so when I say confirmation bias means that the model's own learning table becomes a little bit weak, and whatever you say becomes true for the model at every time. So whatever you say, that is this true in this particular context, right? If a is having this kind of a medication, this health issue, does should A take this particular medication? And the model say yes, and you say that, are you sure? Then the model say, oh, maybe this is something different, maybe the person has to do something different, and then you just revert back saying, are you sure about it? And the model says, oh, okay, then I make another chain of answers. So by the model, by fine tuning, this kind of a weakness has been coming to the limelight when the model tries to go about. And if you say that this is not right, this is the right thing, it just goes with your answer that you are the right person to say. So there is this weakness in the model's weight that comes into limelight when you do fine tuning. The reason is that when you do the fine tuning, you only work on your data set, which I think what Manas also was highlighting, that you need people make specialized data set to do fine tuning in a particular manner. But that also weakens the generalizability of the models across various applications or various tasks. And now you cannot keep on developing data sets for every task and keep on fine tuning it, because in some of the cases that what Roberto was mentioning, you need straight answers, you don't need fine tune answers. So fine tuning is required or not required, that's a very good debate to do it, but I would recommend that if something can be done with RAG and something can be done with some factual knowledge, I think I would prefer that over a fine-tuned version of generating an outcome. So apart from that, there is another issue that I want to highlight is that when I take a fine-tuned model, let's say for clinical BERT, which is for the clinical data, and if I turn that clinical BERT into psych BERT, which is for the psychological data, it loses the memory of the clinical BERT. Right, so that is a series, and if I want to do it, like I can take the psych BERT and I want to train it on a mental health data and make it for mental BERT, it will lose the properties of psych BERT as well as the clinical BERT. So there is a series of catastrophic forgetting that comes into the limelight when you do the fine tuning. So fine tuning is not simply ensuring that your model's training is good and the loss is coming down. It's more about what are your rewards by that training of your fine tuning. Right? Is it so you don't do blindly fine tuning over the multiple data sets. It has to be driven by what are your rewards. Like I want to keep my semantic relatedness. Maybe I want to create. I want to mention. I want to ensure that all my entities are important and they are always given high priority over common used words. Things of that nature. So that kind of a reward based training, if happens in fine tuning, maybe it will save the model from losing its model. Otherwise the model's internal attention gets very weak with the fine tuning design. So that's one. These are my like points that I would like to highlight in the fine tuning and the RAG debate.
So I'm aware of some of the work that you guys have been doing through the different presentations and conversations we've had in the past. Maybe we could talk through some of these use cases in the mental health and healthcare settings at large. Would anybody like to share, or maybe we can start with Manas Gaur? He's had some experience developing expert systems for mental health diagnoses. Do you want to just talk a little bit about that work and how you built that model and how it was employed in production?
So essentially, the closest production that we did was with the Prisma Health in the University of South Carolina, where we essentially developed a conversational system which can do active interactions with the user, and passively it can create graphs, active graphs, I would say, of the conversations, and then improve that graph over the time by UMLS or Unified Medical Language System and SNOMED CT and other knowledge bases. Right, so we did this work with an idea that the model's interaction should be governed by its attention to the key concepts being given by the user. So the idea was that if we want to use key concept, we want to look at to the entities, and we want the model to pick only on the entities part. Right, so that's why we started creating a visualization graph of this work, and then using that graph to come up with an short summary of what the entire conversations happen to be. Right, so that was one part of the work. The other part of the work that we did was looking at redesigning the attention modules of transformer models and moving from self attention to cross attentions. Now, when I say cross attention, people do talk about cross attention in the form of attention between encoders and decoders. We are looking at the cross attention as the attention between the model's representation and the knowledge graph representations. So we are looking at the representations between the questions within the clinical guidelines and the internal representations of the models. So let's say I have a question Q1 and I have a model's internal representation. I want to look at the similarity between the two. Right, so I can model it as a cosine similarity problem. I can model it as a KL divergence problem and things of that nature. Right, so this is the second line of the work in the context of this is all about predictions. The first one was more about conversations in specific, and the third component that we were excited to look into was in the context of one word that Roberto actually talked about in his slide called regulatory compliance. Right, so in the United States, there are various governing bodies that actually decides the decisions for mental health treatment. There is a state level budgets, and then there is a hospital network level budgets, right? And if you want, and all of these budgets means that they are every particular clinicians to be involved has to have certain set of time, hours, and his capabilities and experience, right? And for example, and also it involves that whether the particular user or particular patient is liable to the treatment or not, or is it is that treatment applicable to that person. So there are multi factors to it. Now in that scenario, how would you have a constrained model that looks at the mental health knowledge, looks at the budgetary constraints, look at the capabilities of the patient, also look at the capabilities of the doctors, and then look at the conditions of the patient and the demographic parameters of the patient as well, to figure out that whether this person should be seeking clinical care, should be looking at the monetary level care, or should actually be going for an intensive care, right? So these, and every care decision has a budget associated with it. You cannot recommend someone all the people to the intensive care, because that will overflow the budget level constraints of the state. So we kind of looked at this design of allocating patients across different bands of monitoring one-on-one interaction versus intensive care, to see if AI can do this kind of an allocation in practice. And there are a lot of challenges that came into the limelight in this scenario.
Roberto, would you like to discuss some of the implementation challenges and opportunities that you've seen in the early adopters of IntelliDoctor?
I mean, I think that the for hospitals and clinics, and even for doctors, I think it's early adopters are the ones who make the buzz. So it's very important to engage with them, to really show that this is a new tool that we are engaging in a journey, and from a business perspective is to engage them and trying to get them near you, get feedbacks and incorporate those feedbacks into the product. Because a bad experience can jeopardize your whole initiative. So it's good to do that. And hearing what they say is that what drives maybe the word of mouth. So for us, the feedback that we have is sometimes the answer that we provide is too detailed. Sometimes they would like a shorter response, or vice versa. Sometimes they think the level of information is too broad, while they need perhaps more a narrow, deep information. And also does not forget that a clinical decision support system doesn't stand by itself. It needs to be integrated to the doctor's workflow. So the need to integrate to electronic health records, it is very important. And for that, I mean, this is there's a variety of electronic health records in hospitals. And one thing, at least here in Brazil, we don't have a standard of interoperability between those electronic health records. So our task becomes very challenging. So this is the insights that we have so far. While technology is good, we strive for technology. This is what we love. But from a business perspective, we fall into mundane constraints, which we need to tackle like business as usual.
Thank you, Roberto. Manas, Talukdar, you've probably seen a broader range of different use cases and in various scenarios. Label boxes technology is something that could be applied in a variety of settings, whether it's agriculture or healthcare or whatever requires a multimodal approach. Are there some particular use cases that you can highlight from your expertise and experience?
Well, for mental health, I mean, there's already some domain-specific models out there like Mental Bird and so forth. Now, which have actually, this is published literature, which have shown some promise in detecting, say, depression or suicidal tendencies compared to, say, generalized models. Now, there is a very important point here, particularly where mental health is concerned. I think privacy is paramount. So we have to tread very carefully when providing any sort of training data related to mental health. I mean, there cannot be any compromise on privacy. So that's one. Now, the other thing is, other use cases are, say, chatbots, right? I mean, I know there's chatbots out there in the wild which are used for cognitive behavioral therapy, for example. I mean, I remember coming across something in a publication called Replica or something like that. I'm just saying off the top of my head here. So I think in terms of established treatments like CBT or DBT, so forth, yes, LLMs can absolutely be used. That is a definitive use case. I think in terms of, say, parsing an individual's publicly available data like social media posts and so forth, and detecting whether somebody is in a state of depression or suicidal tendencies, that can be used. But in terms of other things like the therapy notes, using that as inputs to a LLM, I think we have to tread very carefully here.
And then in clinical settings, or you mentioned radiology as an example. Anything else that you can point out?
Well, radiology is one example. The other example in clinical settings could be, patient history, for example. Again, that has to be, when training, it has to be anonymized. No question about it. We simply cannot have such sensitive data going into some public LLM. Obviously, if we are fine-tuning, we would create a private instance, but even then there can be some privacy concerns. So I think anonymization is a pretty important factor here. Removing any PII, personally identifiable information, is pretty important. Use cases, radiology is the glaring use case that keeps popping up more frequently, because that's probably the easiest thing to do. The other use case is obviously patient history, and then figuring out what might be forthcoming and so forth. But anonymization is paramount there too.
Excellent. Well, I think we've gotten a lot of knowledge and insights from all your respective perspectives. One of the key things that is still an open question, or an open question mark for me, is the development and productive use of proprietary training data that is valuable and can be fed into these models. Can we talk a little bit about some of the ideas or methods that you guys are using to capture this training data and then leveraging it to improve the function of your AI systems?
Can you come again one more time, Joaquin? I missed your question.
What methods are you using to collect proprietary training data that is used to fine-tune or improve the overall function of your AI systems?
Okay, so from my end, we did not collect proprietary data. Most of our designs have been on open source and publicly available data, gathered from PhysioNet, for example, that came from social media, for example, Reddit. It was one of the sources that we extensively used. We also had access to some of the data from Reach Out, which is the healthcare platform in Australia. We had access to some data sets from Instagram and Twitter long time back. So I think we always worked on the healthcare, specifically from the side of mental health. We worked only on the social. Like, we had one access to the proprietary data, but I would not say it's a proprietary, because the University of Southern California actually made it public. It's it involves the interaction between the patients and the but it was actually through a Wizard of Oz method that they have gathered the data set. So I would not say it's proprietary. And yeah, so we really like, as I said, privacy is definitely a concern in the mental health space. So a process of deduplication and process of removing PIIs, and recently where we are seeing this new terminology of machine learning coming up into the limelight. It seems like a lot of the things that the model has learned over the training time is not something that the model should have learned. So now I think we are being like saved by this thing that we have worked only on the public level data and not proprietary. For the training of the models, I think the public level data that we have was substantially big. We had communication around like 14 million communications from Reddit that were used for doing a lot of experiments over or developing custom models for mental health. We also explored various ways to improve BARD. I was involved in one in the also in the context of developing mental BARD and those kind of models as well. And PSAT that we just recently released is also a model which is trained completely on the social media conversations. I think that's pretty much from my side on the training, as far as training is concerned. Yes, but we do explore proprietary models, but we only use those models whose access to us is through an API, and we are regulating that API. In some cases, we even have sent an email to OpenAI to give us thoughtful, like a careful access, where there's someone from there who has access, who is accessing and what kind of information we are giving to the model. Because a lot of the questions in the mental health are not answerable by proprietary models. So you cannot explore GPT-4, GPT 3.5 kind of models on those things, and that's one of the limitations in the mental health space. So we only focus on Llama, Mistral, BART, T5, Flan T5, and all these models for the mental health training.
In our case, we're not allowed to use the proprietary data, especially from patients. So we have very strict rules, and so we don't use it. As far as our RAG, as of today, we only use content that are free, that are open, unless we have a kind of deal with a specific customer that he provides its proprietary information to add to the knowledge base. As far as to use the data to improve our models, our algorithms, we try to use public data sets like the Mimic one, Mimic 4, which is a traditional database that has in US, that has like electronic data health records anonymized. So we tend to use models like that to test our ability to our models to capture this structured data and turn into useful information. And that's it. One thing that we are looking at is to partner with public universities, those that has medicine schools that have academic interest to use this data within partnerships, strictly partnerships, so we can work hand in hand to use this information with the professors and to the academic researching area to generate new knowledge and publish and things and this knowledge become available to the public as well. So this is a third way we see and we are pursuing right now.
Anything to add to that, Manas, Talukdar?
Well, I think Manas and Roberto have covered most of it, but I would re-emphasize that these generic models do not work off the shelf for mental health cases. I mean, the example I gave, like mental BART, is a very domain-specific model. So for LLMs, off-the-shelf LLM is not going to work simply for. In fact, it would be extremely unwise to use an off-the-shelf LLM for mental health cases. And I will also say, particularly in the medical domain, I mean, we have to tread very carefully here because the margin of error is very low. And there's a saying in the industry: "You fake it till you make it." I mean, that is simply unacceptable where a human being is concerned, which is paramount in the medical domain. So domain-specific models have to be used. Off-the-shelf LLMs are not an option. And then obviously for proprietary data, it has to be anonymized. No question about it.
Great. Well, we're nearing the end of the panel discussion. So I'd like to just ask, what are some of the optimistic views and roadmaps that you are pursuing in your own work that sort of gives us some insight into what's coming next?
So in my in my lab, what we are looking into is going towards more smaller models which are manageable, customizable. I can add lot many modifications to it, and increasing the way I can represent knowledge to support those models. Like should I am I would be would I be looking at only the RAG design? Would I be able to look at RAG plus graph design? Would I be using some sort of a better retriever, right? Or would I be looking at a better representation model of the knowledge and things of that nature? So separate to this, we are also exploring some intricacies inside the model, such as looking at rules of thumbs, which is the model's tacit knowledge, the model that the knowledge that the model has learned, and looking at the ways to elevate bias through knowledge as opposed to adding more data sets. So I can talk about, let's say, the three directions that we are looking at is one is customization of the models based on the knowledge. The second is looking at bias and debiasing with the use of knowledge as opposed to more data. And the third component that we are looking at is more towards rules of thumbs, which is we are looking at how do we extract rules from the model from various forms of training and use those rules for the downstream tasks. So those are more cheaper, smaller, manageable piece of information compared to the gigantic LLMs.
Yeah, so from my perspective, basically the theme continues to be to provide high quality ground truth training data to whether it's the large companies developing LLMs or whether it's to other companies who want to fine tune their LLMs or create their own private instance of the LLM for a specialized use case, whether it's for reading medical records, whether it's radiology, or whether it's mental health chatbots and so forth. So that's the priority. And at Labelbox, we're basically committed to providing an internet scale platform that can enable providing high quality training data for these use cases.
Yeah, I think for our perspective, we are heading towards the same thing as Manas talked, Manas Gaur, in using lighter models and enhance our knowledge retrieval. For that, we and why? Because we are moving towards being more niche. So we see that we should go towards the movement of vertical. So we have a vertical of oncology, for example, or a vertical of cardiology. So then we need to deep dive in protocols, guidelines that are issued by societies of cardiology in Brazil, for example. And there's a lot of challenge there. One of them is that those documents that these societies, for example, they publish, it's very large documents, more than 100 pages. So you cannot simply put this into a RAG and wait for the LLM to decide what is the relevant information together. So you need to have a information representation model of these documents and to make sure you extract what is needed. And this is an area of research. I don't know the answer, and I'm glad to write after this event to engage with Manas Gaur and know more about what are the techniques and the things that he's using for that.
Well, excellent. Thank you very much, gentlemen. It's been a pleasure to be in this panel discussion and learn from you all. I have no prior background in healthcare or pharma, so just being able to learn from you guys and get a better understanding of what's coming down the pipeline has been deeply enriching for me. We're at the end of the fourth day, so with that, tomorrow is going to be the last day of the AI Expo. Enjoy, connect with each other, and we'll see you tomorrow.
Thank you, Joaquin.
Thanks, everyone.
Very nice to meet you all. Thank you for the opportunity.
Thank you, everyone.
It was a pleasure being part of the panel. Thank you. Bye.